Hi, I'm Randall Heyman, a mathematics academic. Because of the coronavirus outbreak, I'm using my YouTube channel and this Corona Help playlist in particular to help lecturers, tutors, high school and primary school teachers, parents, grandparents and students with any mathematical problems or concepts that they're having. If you'd like me to make a video for you or your students, comment below under this video or drop me an email. So this is the third part of a series of videos I'm doing on metric spaces for Lydia, who tells me that she lives in the United Kingdom. So I thought what I'd do is prove that something is a metric space. So this is the one I'm going to do, which is the taxi cab example that I showed you from the previous video. So show that R2D is a metric space where the distance function AB is given by this formula here. And this is for all points where A and B are, as you would sort of expect, A1, A2 and B1, B2 respectively. I'll just point out here, this is sort of the way we would represent a metric space, a bracket and then the space that's involved, and then a comma, and then the metric function that we're using to create the metric space. So if you're going to show this, you might want to sort of say, firstly, R2 is a non-empty set. So one thing I didn't say before is that the set that you use must be non-empty, is a non-empty set. Next. So now we go to those three properties that we need. And the first one is a double header. So the first thing is that we need that DAB, the distance from A to B, has to be greater than or equal to 0. So DAB, well, you wouldn't need to. These are just two numbers, A1 and A2. They're just the coordinate, numbers that come from the coordinates. And this is these are the absolute value symbols. Actually, sorry, to do that properly, these are the two that indicate that we're talking about an absolute value. And an absolute value is greater than 1. We have that is greater than 0, greater than or equal to 0. And B1 minus B2 is greater than or equal to 0. So DAB, which is equal to A1 minus A2 plus B1 minus B2 is greater than or equal to 0. Next, distance A to A is equal to A1 minus A1. Let's think this through. We've got A1 here. Sorry, A, which is A1, A2. And we had over here B, which is B1, B2. So if A is the same as B, we'd be going A1 minus A1 plus A2 minus A2. And that certainly equals 0. And maybe what we should do actually is put also here rather than next to it. Let's just write, whoops, let's just write also there. That, and A does not equal to, if A is not equal to B, then either A1 will not equal B1, or A2 will not equal B2, and so DAB will not equal 0. So we've shown that here, so far, what we've shown is that the distance function is always positive or 0, and it's only equal to 0. Well, it's equal to 0 if and only if the two points are the same, A equals B. Next, what else have we got? That should actually be a comma, I think. Next, we need symmetry. So DAB equals A1 minus B1 plus A2 minus B2. And we can just swap that around because it's just the absolute value, doesn't change anything. And that equals DBA, so that should be sufficient there. And then finally, actually with these normally the last one, that triangle inequality, is the hardest. Finally, there's a little trick here I'll show you. Finally, DAB equals A1 minus B1 plus A2 minus B2. Finally, actually, let's put up here, let C be the point C1, C2. Then DAB is that, okay, now what we do is a little shifty little trick. A1, this A1 here, A1 minus B1 is actually equal to A1 minus C1 plus C1 minus B1. And we can repeat the same trick. And what might help here is if I can write little brackets there. Now, we know from the triangle inequality, just for the absolute value, if you just look up, go back through your notes when you learnt the absolute value, you'll see that the triangle equality works just for the absolute value. So this first absolute value here, we can just put it's less than A1 minus C1 plus C1 minus B1. And this one here is less than or equal to A2 minus C2 plus C2 minus B2. And I suppose if you were going to do this properly, you would go, you'd rearrange this a bit to make it exactly what we want. These are all absolute values, and this is equal to these first two. So this one here and this one here, that's just equal to the distance from A to C. And this one here is just equal to the distance, strictly speaking, this is the distance from C to B. But because of what we've just shown before, equals DAC. Actually, that's exactly what we want. Actually, that's exactly what we want. That's exactly what we want. So what we've shown, if you go back up to here, the distance AB, and from here is less than or equal to this distance plus this distance. And so D is a metric. If you want, you could write here function. So I think we've done enough now to say, therefore, the set R2D, sorry, the metric space R2D is a metric space. And just to fill in a little bit here, this was the shifty line that helps. This is the triangle inequality for the absolute value. So that gets us to there. So this was just a rearrangement. We just changing the order of which we're adding things. And then this just came from the definition of D. Okay, so I think we've done enough. If I was marking this, I'd give it a tick. Any questions on any more questions? Well, actually, let's do this properly. Any questions on any of the 3 videos I've done on metric spaces, please comment below or send me an email. Same if you've got any questions about metric spaces at all. And finally, if you've got any questions about mathematics, comment or email and I'll try and help.